I'm going to illustrate the stability of the first order ODE. Y prime is equals to lambda y subject to the initial condition y at t equals to 0 is equals to y naught. For me to illustrate the stability, I'm going to use a free application which can be found on MacBooks or any iMac. And the application is called Grapher. So what you can do is you can go to your Launchpad, then go to Other, then go to this one, this app, Grapher here. So I will just choose the default here. So when I've chosen the default, then I go on and enter my equation. So I'll just remove what is here, then enter the equation. Our equation is the derivative of y, the y prime. So it's y prime is equals to, and then we are saying y prime is equals to lambda y. So I can go here on the palette here, then look for the lambda, the grid here. So the lambda is this one here. So it's equals to lambda, it's equals to lambda y. So that's our differential equation here. Then we need to enter the initial condition. So for the initial condition, it's y at 0. When I in a graph, the independent variable is x. So instead of using the t that we've been using before, we'll be using x as the independent variable. So it's saying 0, then is equals to. But when you are looking at stability, we need different values of the initial conditions. So for the different value of the initial conditions, I can name it alpha. And then I can go on and click on the return key. Yes, you can see it's still giving an error here just because I have not specified the values of the lambda and the alpha. For me to specify the values of lambda and alpha, I click on the plus here, then click on new equation. So now new equation, I need to enter the values for alpha. So I'll click on my alpha here is equals to. Then for stability, we are looking at different values of the initial condition. So it's a set of values. At a set, we usually denote it by braces. So we open braces there. And I'm going to enter different values of the initial condition. I can have 0.1, and then put a comma, then 0.2, then comma, then 0.3. I'll just put this just as an illustration, then click on the return key there. Then I can go on and enter the values now for the lambda. Because we're having y prime is equals to lambda y. So let me now enter the values for the lambda. So I got a new equation. And for the new equation, we are now entering for lambda. So lambda is equals to. So for now, I can set my value of lambda to be a 1. Then click on the return key. So when we put the 1, let me just close this. If we can see, it has plotted now the solutions. These are the 3 solutions for the 3 different initial conditions, 0.1, 0.2, and 0.3. And as you can see, as x is increasing here, but the distance between these graphs is increasing. Here they were so close, but as x is progressing, the distance is increasing. So what we are having there is, as the independent variable is increasing, the solutions are getting further and further away from each other, which is contrary to the statement that you said the changes in the solutions will be small. So what we are seeing here is if lambda is positive, like a 1 there, the changes here, they are not small, they are getting bigger. Yes, the independent variable is increasing. But we can now change if we want, and we can put now a negative value there for the lambda. So if I put -1, then you'll see what happens to the solutions. I'll click on the return key. And as you can see, yes, x is increasing the independent variable. The changes in the solutions, these differences, they're getting smaller and smaller. Both here they were bigger, but as x is increasing here, the solutions are becoming smaller and smaller, up to approaching almost the same value here. So what you are seeing here, we are illustrating that this differential equation y prime is equals to lambda y. It has stable solutions if the lambda is less than 0, it's negative. Because if it was greater than 0, you saw that the solutions were getting further and further apart for the different initial conditions. Here I was just illustrating with 3 initial conditions, but you can put as many as you want. And You can do that by just changing here. Because here we're having 0.1, 0.2, 0.3. I can even put another one, 0.4. Then click on the return key and you'll see that there will be a fourth solution there. So you can put as many solutions so that you can analyze the stability graphically by just seeing what's happening on the solutions there.